Okay, so our first unit is called Linear Systems, and the first lesson of that unit is called Solving Systems by Graphing. So here I will go through just to give you a little bit of introduction as to what is a linear system, how do you solve a linear system, and we'll go through a few examples to help you understand that concept. Alright, first of all, in grade 9, you've studied linear equations. So for example, you've probably studied 2x plus y equals 3. Now what we're doing is we're studying a linear system. So we're looking at two or more equations simultaneously. For this particular unit, we'll be looking at two lines simultaneously. So anytime we look at two lines together, we call this a system of equations. Now to solve a linear system of equations means to find the point or points where the lines intersect. So when you're going to look at two lines together, when you draw the first line, for example, and if you draw the second line, what we're interested in knowing is where do they meet, and that is what we're going to call the point of intersection. In other words, our solution. So that's going to be our solution. So in order for us to do that, we're going to have to graph both lines and figure out where the point of intersection is. Along with that, you can also check your work by substituting into the original equations to see if left hand side equals right hand side. And we'll do an example of that where you can see the check method happening as well. Okay, so let's go to the first example. It says find the point of intersections graphically, meaning you got to graph both lines and figure out where do they meet. So we got to make sure when we're graphing lines, they're into the format of y equals to mx plus b, where m is your slope and b is your y-intercept. And just to do a little recall as to how you're going to graph this line, you always start off by plotting your y-intercept, which goes onto the y-axis, and then you use your slope to graph simultaneous points, and then you're going to join all those points with a straight line. So for example, we're going to start off by labeling our equation. It's equation number 1, equation number 2. This is all into the form of y equals mx plus b. And so this one, y equals mx plus b. So we're going to go ahead and graph this. For the first equation, my y-intercept is a negative 5. So let's go ahead and do that. I'm going to label my axes first, x and y-axes. And negative 5 is 1, 2, 3, 4, 5. So negative 5 goes into the y-axis, y-intercept. My slope is 4. That's 4 over 1. So my rise is 4, run is 1. So I'm going to rise 4, 1, 2, 3, 4, and run 1. And you can do that as many times as you like until you think that you can draw yourself a straight line. I can stop right there and draw myself a straight line. But just for more accuracy, I'm going to go ahead and plot more points. So 1, 2, 3, 4, 1 across, 1, 2, 3, 4, 1 across, and I think that should be good. I'm going to join all those points now with a straight line. Make sure you guys are using a ruler. And make sure you draw yourself arrows because that line will continue on. And we're going to go ahead and label our line as well. Y equals to 4x minus 5. Okay? And I'm going to grab myself a different color pen so I can distinguish between the first line and the second line. My second line, my y-intercept is a positive 5, so I'm going to go ahead and plot 5 on the y-axis. That's 1, 2, 3, 4, 5. And my slope is 2 over 3, so my rise is 2, run is 3. So I go up 2 and 3 to the right, and I can figure out where the lines are going to intersect, so I don't need to go ahead and draw any more points. I'm going to now join my point of a straight line. I'm going to extend my line, draw arrows because that line does continue on, and I'm going to label that line y equals to 2 over 3x plus 5. And here you can see the point of intersections right there. That's your solution. In this case, it happens to be 1, 2, 3, and that's 5, 6, 7. So that's going to be 3 and 7. So point of intersection is always written as x comma y. So the x coordinate comes first, then the y coordinate. X coordinate is 3, and the y coordinate is 7. And make sure you guys are writing that in a coordinate format. Okay, good. Our second example is very similar to the first one. So I'm going to do this one in class, and I'm going to move on to the third example where we're going to do a little check as well. So we're going to have to figure out the point of intersection and make sure to see if that indeed is the point of intersection. So here, the first thing you gotta do is label your lines. So my equation number 1, equation number 2, this is a linear system because I'm looking at two lines simultaneously. So looking at two lines together. In order for me to graph, lines must be in the format of y equals mx plus b. And if you notice here, they're not. So I gotta do some extra work here to try to format that into y equals mx plus b, and then go ahead and graph them. So the first line here, I'm gonna move my x to the other side. So I have 2y equals to negative x plus 4. So when that positive x moves to the other side, it becomes a negative. And I'm going to go ahead and divide both sides by 2. So that becomes y equals, so 2 cancels. It's negative 1 over 2x plus 2. Because 4 divided by 2 is 2. And then have a 1 in front of that x. So it's a negative 1 over 2. I'm going to do the exact same thing with my second equation, put that into the y equals mx plus b. So in that case, I'm actually going to move the negative 2y to the other side, so I make it a positive, and I'm going to move that positive 4 to the left-hand side. So that's 3x minus 4 equals 2y. I'm going to rearrange this, so I'm going to flip this around. So I have 2y equals 3x minus 4. And I'm going to divide both sides by 2. So my 2's here cancel. I have y equals to 3 over 2x minus 2. Okay, so now they're into the y equals mx plus b format. I'm going to go ahead and I'm going to graph those lines. So I'm going to start off by labeling my axes. That's the x and that's the y axis. And if you notice that the first equation, my y-intercept is a positive 2 and my slope is negative a half. I'm going to grab myself a different color so I can actually see that. It's a little bit hard. So here, y-intercept is a positive 2, so it's 1, 2, right there. Slope is negative a half, so I go down 1, 2 to the right. So down 1, 2 to the right. I'm going to do that several times so I get more accuracy in my line. So down 1, 2 to the right, down 1, 2 to the right, down 1, 2 to the right. And I'm going to now extend that line. Just like how I did down 1, 2 to the right, I can also go up 1, 2 to the left. That's the same thing. Up 1, 2 to the left. And I'm going to extend that line, draw myself arrows, as well as label it. So that's going to be y equals to negative a half x plus 2. I'm going to go ahead and graph my second line. And the y-intercept is a negative 2. So it's going to be a negative 2 right there. And my slope is 3 over 2. They're both positive. So I go up 3, 2 to the right. 1, 2, 3, and 2 to the right. And I can see where that meets immediately. So I'm going to stop right there. Draw myself the line. Arrows. And then go ahead and label it. So it's y equals to 3 over 2x minus 2. Okay, great. So my point of intersection is right there. That's my solution. So point of intersection is always x comma y. So in this case, it's 2 comma 1. Okay, so we're going to go ahead and check to see if that is indeed the solution for that system. So since it's a system, I got to check to see if that is the point of intersection for both of my lines. So let's do check. For the check, I'm going to start off with the first equation. So you're going to set up a left-hand side, right-hand side, and you're checking to see if that point of intersection is 2 and 1 is a solution. Alright, on the left-hand side of this equation is x plus 2y. On the right-hand side, it's a 4. This is your x coordinate, that's your y coordinate, and you're simply plugging in 2 for x and 1 for y. So that's 2 plus 2 times 1, that's 2 plus 2, that's 4. And here, left-hand side does equal right-hand side, but you're not done right there. You got to do the exact same thing with the second equation as well, because this is a system, and you have to look at both equations together. So my second equation, I'm going to set up my left-hand side and right-hand side again. And I'm going to check to see if the point of intersection 2 and 1 satisfies that equation as well. On the left-hand side, I have a 3x minus 2y. On the right-hand side, it's a 4. So I'm going to plug in for y. So that's 3 times 2 minus 2 times 1. And that's 6 minus 2, which is a 4. So left hand side does equal right hand side. Therefore, the solution, so point of intersection, x comma y, is indeed 2 comma 1. And you've already checked your work for that. Alright, great. And our homework for today, which you guys are going to do in class, is page 16 to 19, communication number 3 to 5, as well as numbers 1 to 4, 5A, 6 to 9. If you want to get a head start at home, please do so. Alright, thank you.